Today we shall be considering transformation. When we talk about transformation, this has to do with causing changes to the original shape. The original shape is what we call the object. In order to obtain a new shape that we call the image. Such changes could be by changing the position, flipping, resizing, or turning the original shape in order to get a new one. And under this topic, we shall go through or put us through these four subtopics. The number one is what we call translation. Then we talk about reflection, we talk about enlargement, and we talk about rotation. Talk about shear and stretch. So when we hear translation, what does it mean? Translation simply means to slide an object on straight lines. When you slide an object, whether sideways, forward, backward, but on straight path. That is what we mean by translation. When we translate, when we move an object on a straight path. Then what do we mean by reflection? Reflection, there's no reflection without what we call mirror line. A mirror line is popularly known as line of symmetry. So we understand that, for example, if I put mirror before myself, if I'm facing front, then my image will be facing backwards because if I put my mirror, I will be seeing myself. That means the two faces, the original and the image, they both face each other. That means the original is facing front, the image is facing back, facing my back. So in other words, when we talk about reflection, it's a way of flipping an object. When you flip an object, we talk about that you reflect it. So an enlargement. Enlargement in this sense does not connote what we have under language. Under language, when you enlarge something, you make it bigger. But under mathematics, enlargement means to resize something. That is, you may resize something to make it bigger, or resize something to make it smaller, depending on the ratio or what we call scale factor that you use to enlarge. And lastly, we will talk about rotation, when you turn an object through an angle. But for the purpose of our class, we shall restrict our angles to multiples of 90 degrees. So that is, we talk about when you reflect an object through 90 degrees, both clockwise and anti-clockwise, through 180 degree. 180 degree does not have whether you turn an object 180 degree clockwise or anti-clockwise, you still get the same value. So we simply say 180 degree. Then we have 270 degrees. 270 degrees clockwise has the same result as 90 degrees anti-clockwise. So when you talk about 360 degrees, 360 degree will bring the object back to its original position because it has completed the whole turn and come back to the original position. That is why 360 degree and 0 degrees coincide. And we'll be taking this example quickly. The example says that draw a triangle ABC with the coordinates given. We have coordinate of A to be -3, 3. We have coordinate of B to be -2, 1, and coordinate of C to be 0, 3. So we'll quickly draw this. When you draw, then you begin the following transformations. So we get an image A1B1C1 of triangle ABC under a reflection in the line y equals to 0. And that is why I said for you to reflect an object, there must be a line of symmetry, a borderline on which you are reflecting. Because, okay, let's move on to the graph first. So the coordinates, we want to quickly provide the objects based on the coordinates given. The coordinate of A is -3, 3, when X is -3, Y is 3 at this point. So we put point A here. Then B is -2, 1, -2, 1 from the question. B is there. And C is 0, 3. 0, 3 is the value of Y-intercept here at 3. That is C. So we use a ruler to join the 3 points together. That is point A to B to C to form out a triangle. So this is the triangle now. This is the object we want to reflect in each case as given by the question. So we'll quickly check on what we have in the question. Dear students, the essence of this project is to complement the efforts of your classroom teachers on different math topics. The contents are already arranged topic by topic under the playlist on my YouTube channel. And the goal is to have all the senior school math content covered, as well as junior school, including the upper primary school, especially for entrance exams. Question again. In the question, we have that we have triangle A1B1C1 of triangle ABC under a reflection in the line y equals to 0. So if you go back to line y equals to 0, where we have line y equals to 0, line y equals to 0 simply means if I say y equals to 2 now, that means I'm going to draw this line. If I say y equals to 2, or y equals to minus 2, for example, I'll draw this line, y equals to minus 2. If I'm giving y equals to 1, I will draw this line here to pass through y equals to 1. But if they say y equals to 0, that means the line I should have drawn will coincide with x-axis here. So line y equals to 0 is simply x-axis. And conversely, line x equals to 0 is y-axis. So that means we want to reflect this one in the line y equals to 0, which is x-axis, and the line is already drawn here for x-axis. So what we do is, how do we reflect this? When you are reflecting this one, since our mirror line now is this, our mirror line is this line of symmetry, which is x-axis. So you now check this image, this object will come back down to the opposite side. Since it is above the mirror line, to come down to below the mirror line. So it will just reflect to the opposite side of the line. So since the line is horizontal like this and the object is up, then the image will come down below the mirror line and will maintain the same distance as before. Now, if you check from this mirror line to this position where we have A, how many units above? Like 1, 2, 3. 3 units above. So that A1 will now come down 3 units below. 1, 2, 3. We start the counting from the mirror line x-axis. 1, 2, 3. So our A1 will be here. A1 will be here. Then B1, if you look at B, above the mirror line is x-axis. It's just 1 unit above. So it will be 1 unit down. So that is B1. And for C, C2 is 3 units above the mirror line. 1, 2, 3. It will come down 3 units down. 1, 2, 3. So C1 will be here. The next thing you do as well is to use your ruler to join the 3 points together and form your image triangle A1, B1, C1. Join them this way. So you can see that under reflection, the size of the original object is not altered. It's still the same size, but it's just that the position has been shifted. The position of A is no more here. It is now here. So and we can see that if we imagine that we want to fold this paper along this x-axis, the two shapes, both the image and the object, will coincide. They will match each other such that A1 will match A at this point, B1 will match B at this point, and C1 will match C at this point. And that's the essence of what we're given before in the question, where they give us in the question that if you look at it, they say A maps A1, B maps B1, and C maps C1. That is under reflection if you fold it along that. So we go to the second one, A2, B2, C2. Under reflection, the line x minus 1 equals to 0. X minus 1 equals to 0. That means we want to reflect triangle ABC to get A2, B2, C2. But the line, the mirror line we are giving this time around is x minus 1 equals to 0. And this one implies if you solve x minus 1 equals to 0, it's same thing as x equals to 1, line x equals to 1. So you go back to the graph and say, where is line x equals to 1? Line x equals to 1 is, this is it. X equals to 2, so x equals to 1 here. You draw, you can make it a broken line. So line x equals to 1. So since we need to reflect triangle ABC on this line, so we just check for A. If you look at this line is a vertical one. So that means the whole of this object to get its image, since it is reflection, to jump to the other side. Since this object is to the left of the line, mirror line, to jump to the right. So if you look at the line from here, how far away is A, object A, from that line, from this place? That is 1, 2, 3, 4. So it will come to the right by that 4. 1, 2, 3, 4. So we'll put points A2 here. This is a 1, 2, 3, 4. A2 will be here. Then C, for C, how far is C from that position? It is just 1 unit to the left. So it will come 1 unit to the right. That is C2 here for this position. And for B, from this place, 1, 2, 3. So to come from here, 1, 2, 3. So B2 will come to this place. And as well, we use a ruler to join the 3 positions together to form our image A2, B2, C2. And that will form the second value on this. So when we are done with this, we quickly do the last one. Okay, this is the second image. The last one that we'll quickly check, they ask us to draw an image triangle A3B3C3 of triangle ABC. That means this one too is an image of ABC. Sometimes it could be A3B3C3, could be an image of A1B1C1. In that case, that means we use A1B1C1 as our object. But here they say it's still of ABC. That means ABC is still our object. Under a reflection in the line y equals to x. So we go back and say line y equals to x. You must always first draw the line when they give you. Line y equals to x is what we want to draw. To draw line y equals to x, if you look at what equates x and y together is when x is 1, y is 1. When x is 2, y is 2. When x is 3, y is 3. When x is minus 1, y is minus 1. When x is minus 2, y is minus 2. That's line y equals to x. That means it's line 45 degree along this axis, along this quadrant, and line 45 degree also along this quadrant, along the first quadrant and the third quadrant. If it is line y equals to minus x, that means when x is 1, y will be minus 1. When x is 2, y will be minus 2. Or when x is minus 1, y will be 1. That is for this fourth quadrant and the second quadrant here. So here we are going to draw the diagonal that will connect, that will put both value of x and y, and that is the line. Okay, that's the line. That's the line. So we want to reflect this ABC along this line. Since this line is not a vertical horizontal line, it's a slant line. So the counting will be along diagonals. So let's see how we have this done. So for point A, point A is how many diagonals away from this line. If you reach point A, you know it is this. You can read it along here. Just read it along here to point A. You can see how many diagonal is that? This is first full diagonal, second full diagonal, third full diagonal. So I want to count it. Since it is 3 diagonal from here, 1, 2, 3 to the line. And we know that this object will jump to the other side to be from here, 1, 2, and 3 here. So that means 1, 2, 3. That means A3 will be here. Then what about B3? If you look at point B, this is first diagonal 1 and half, 1 and a half. So from here to half and 1. So B3 will be here. And for C3, if you look at C to that line, to the line y equals to x. This one is line y equals to 0. It's good that we indicate our mirror line equation. This one is x equals to 1. Okay, so for this one, if you look at this C from that green line, it is 1 and a half, half, 1. So that means C3 will be here. Then once you get all the 3 points, what we simply do is to join them using your ruler. So we have this. You can see now if you fold this along this line, if you fold this paper along this green line, you can see that this B3 and B will match each other, they will coincide. Then C3 to will match C there, and A3 and A will come together. So this is the reflection aspect of our transformation class.